Hi friends, a very good evening to all of you. In fact, a very pleasant evening to all of you, and we are very happy on behalf of Systemics Club. This is OS Bharat. Uh, we are launching a new initiative called Learn Easy on behalf of Systemics Club IIT Kolkata. So, through this initiative, what we want to do is we'll be explaining some of the problems from subjects like operations research, business statistics, financial management as well. So all the subjects which relate software, that is, we'll be using Excel as well as SPSS softwares, and explain some of the case studies as well as some example problems from these textbooks. As a result, in real business situations, how to use the basic tools in Excel like solver, data analysis. So how to use these tools, we can understand this through these examples. So this is the major objective. Um, so in this first example, what we're doing is we took an operations research problem, a basic LPP problem, linear programming problem, and we'll be explaining how to use solver to solve this LPP problem. So first step, how to install this solver tool. Firstly, go to File, go to Options, go to Add-ins, Excel Add-ins, press Go. So you will get uh, this box where you can just check solver add-in and click OK. So in my data tab, I'll get a solver here, which is not present previously. So now I can use solver for this data. So what basically is this problem? In operations research textbook, page number 13, probably you can find this problem. What actually it tells is that there is a company called Ready Mix Company, and it basically manufactures exterior paint and interior paint. So it uses raw material 1 and raw material 2 to manufacture these paints. What is the 6? It uses 6 tons of raw material 1 to manufacture 1 ton of exterior paint. At the same time, it uses 4 units of raw material 1 to manufacture 1 unit of interior paint. The same case with raw material 2 as well. And there are also maximum limits, that is 24 units can be used daily for raw material 1 and 6 units of raw material 2 can be used daily. And this is the profit function, which is yeah, this is a profit function which is $5,000 for exterior paint and $4,000 for interior paint. So we need to maximize what is the maximum profit which we can obtain by manufacturing these two paints. So yeah, so our objective function would be 5x1 plus 4x2, and our constraints, that is 6x1 plus 4x2 less than or equals to 24, because this is a maximization problem. And similarly the second constraint for raw material 2. So but there are also few more constraints which are mentioned in the textbook. If you see, what it says is a market survey indicates that the daily demand for interior paint cannot exceed that of exterior paint by more than 1 ton. That is minus x1 plus x2 is less than or equals to 1. It also says that a maximum daily demand of interior paint is 2 tons. That is x2 less than or equals to 2. And there are also non-negative constraints. Non-negativity constraints, that is x1 and x2 must be greater than or equal to 0, which is pretty obvious. So having given this maximization function, which is our objective function, and the constraints, how do we solve this linear programming problem in Excel? We must use the solver function, which is here. So yeah, I'm opening solver now. The data is here already. I have created objective function here, and the same data which is available here I have created here. I am using these cells in green as my x1 and x2 variables. So while the iterations are happening, it is these values x1 and x2 which are going to change, and I'll get my final result of x1 and x2 in these two cells, and my objective function would come in this cell. Okay, so yeah, firstly, how to use, we need to input data, the total, which is equals to sum product is a function which I'm going to use here. Yeah, sum product of these array 1 and array 2, that is 5. So what I entered is 5x1 plus 4x2 is equals is less than or equal is the maximization function. So but remember one thing, we need to copy this the same. So we'll be making constants, this x1 and x2 will be making constants. So we'll use a dollar sign there, just plus f4 there, you will automatically get dollar signs there. This dollar sign makes the particular value fixed there. So for example, now see here, now I'll be dragging the same function for the rest of the constraints as well. So it has changed from b4 c4, but b8 c8 has remained constant. Similarly, it has changed to b5 c5, but b8 c8 has remained constant. This is the purpose of dollar sign here. So always remember that we must keep a dollar sign in front of this x1 and x2, so in order to remain constant while copying. This would be very useful. Now, having entered our functions here, now let's go to solver. How to solve this? Yeah, yeah. Here, this is the objective. Objective. Where are we getting the objective function? It is this cell, right? This cell gives us our objective function, and this is a maximization problem. Now, what cells are we changing? That is, basically, it is asking for x1 and x2. Yeah. So these are my x1 and x2. Okay. So I already added here. So yes, now we need to add constraints. What constraints do I have? These are my constraints, right? So I'll be adding them right now. Add. I'll be adding all of them at the same time. Okay. So these are my constraints, cell reference variables, and my maximum limits are these. Okay, and take care of the symbol. This is less than or equals to. Since all these four variables are less than or equals to this, I'm doing this. Okay. So I'm pressing OK. So are there any other constraints? Yes, we have. What is it? Non-negativity constraints. So we'll add one more constraint, which is this. These two should be greater than or equals to 0. Yes. So we have added our constraints. We have added our objective function, and what are our x1 and x2. Okay. So now I'm going to click solve. Yeah, please see that, ensure that it is a simplex LP problem selected. This is a how to solve LPP problem. Yes, I got my solutions finally. That is 3 units of exterior paint and 1.5 units of interior paint are uh, are to be manufactured. So my objective function is this, my final profit function, which is 21,000. Yeah, finally, this is how we'll solve an LPP problem through solver. And by the way, if I have to clarify what are these, I have combined this entire expression, that is this entire expression 6x1 plus 4x2 into this variable. So this variable, this cell should be less than or equals to this cell. This cell should be less than or equals to this cell. So I hope you understood this problem. And the first three problems of our OR assignment is of similar kind. Once if you frame the objective function as well as this constraints, your problem is done. Just use this method, you will be finding all the answers. Thank you very much, guys. Have a nice evening, and probably we'll be covering some of the problems on sensitivity analysis and other operations research problems, and I'll also try to give some of the examples on business statistics like regression and all in the future sessions. Thank you very much. Have a nice day.